Okay, so let's say we have something like this. And you're trying to find the cotangent of the angle. They want us to give it in both degrees and radians, and they give us this cotangent of an angle square root of 3 over 3. How are we going to figure out what the angle is? Now, one thing about it is if we see something like this, we know it's got to be one of two things. We don't know a whole lot of angles in our head, and so the ones that they're kind of expecting you to have down are the 45, 45, 90, and if you remember this is like, if this is 1, this was... let's see, let's solve this. We always know this is going to be 1 because we always have in the unit circle our radius is 1. And this is the same thing as saying like x squared of 2. So if you want to find out, remember if you label the 45, 45, 90, across from the 45 is x, across from the 45 you call it x, across from the 90 degrees is x squared of 2. So if x squared of 2 is 1, I could figure out what x is, in other words. And if I divide both sides by square root of 2, I get 1 over square root of 2. So these are like 1 over square root of 2. Okay. So I don't see square root of 2's in this number. I see square root of 3. So it must mean they're not talking about this one. They must be talking about a 30, 60, 90 triangle. Because again, these two triangles are so important because we really kind of stick to things that are multiples of 45, 30, 60, in order to, when we're doing things without our calculator, we can do a whole lot without our calculator. So if you remember, across from 30, we called it x. Across from 60 was x squared of 3. There's a square root of 3 over here. I'm on the right track. And across from the 90-degree angle, we call it 2x. Now, if I were to try to, let's put the coefficient of 1 here. I could have set 2x equal to 1 and solved some stuff down, but let's not do that. Let's do this. If you think about this number over here, square root of 3 over 3, it's almost like you have to think backwards. What would have been here? There's a radical, and what you kind of got to think here is, where did you start out? Because what they probably did was rationalize something. They probably multiplied something by the square root of 3 over 3 to get square root of 3 over 3. And if you think about it, if you had 1 times square root of 3, you'd have square root of 3 on top. And you would have had to have another square root of 3 times square root of 3 to get 3 here. So it looks like this value started off being this 1 over square root of 3 here. So if you think about cotangent, tangent is opposite over adjacent. So cotangent is adjacent over opposite. If we look at just the coefficients here, if we were to divide the x out, we could actually take that x out. If you think about that triangle up there, you could cut the x out of every one of those terms and just look at the numbers. And because of similar triangles, you could just look at the numbers and actually get your values for your trig function here. What would have an adjacent side, because adjacent's on top of the fraction of 1. It has an adjacent side of 1. That would have to be the 60 degrees, wouldn't it? 60 has an adjacent side of 1. And then at the same time, it needs to have an opposite side of square root of 3. Check out 60 degrees. Adjacent is 1. Opposite is square root of 3. So that would actually be a 60-degree angle. The cotangent of a 60-degree angle would be this 1 over square root of 3. So we're talking about a 60-degree angle here. So we figured it out. Theta is 60 degrees. That's what it is in degrees. They also want it in radians, okay? So 60 degrees, if you think about it, 180 divided by 3 is 60 degrees. So if I substitute pi for 180, pi divided by 3 would be 60 degrees. That's one way I could have come up with it. Remember, the other way is to say pi over 180. Those are equivalent, so what would be equivalent to 60 degrees? And remember, my degrees are going on my bottom of my fraction. So 60 pi divided by 180 would have given you also pi over 3. So I'm having to do a little bit of logic here. I'm trying to think which of these, 45, 45, 90, or 30, 60, 90, even had the square root of 3 in it. And I was down here, that put me down here to the 30, 60, 90. It's either going to be one of the two of those when you're messing with stuff like this, unless they give you a value of 0 or 1. If they give you a value of 0 or 1, that's going to be like these, points that are here on the axis, like 90, 180, 270, things like that. But in this case, this is what we could have done to figure this one out without using our calculator. We didn't really want to use our calculator because, we're trying to do all this by hand. Let's try another one of these, because these are hard to get the hang of, but they're really important. And this is how you end up not having to always look up stuff. You can kind of get better at this as time goes by, I think. This has got a square root of 2 in it, and if you remember our 45, 45, 90s, it was like x, across from this you call it x, across from this other leg's also x, the hypotenuse was x squared root of 2. I know that it's going to be this triangle. If you think about the 30, 60, 90, it had like square root of 3's in it. It would have like a x squared root of 3, and then 2x. So this is not what I want down here. I want to think about a 45, 45, 90. All right. Cosecant is the inverse of sine. So let's think about this. Sine is opposite over hypotenuse. I'm just to think here. So cosecant would be the hypotenuse over the opposite side. We're pretty sure it's going to be a 45-degree angle, because in a 45, 45, 90, that's really all we got. But let's just kind of follow this out. All right, so it looks to me like they're telling me, if you think about this fraction, square root of 2 over 1, I would have a hypotenuse of square root of 2 and an opposite side of 1. Well, if we come in and we look over here, let me put my 1's in front of my x's. I could say similar triangles are always going to have the same sine, cosine, tangent, all the same trig values, because all they are ratios of one side to another side, and they would all reduce to the most basic level. So I can actually cut all my x's out. What angle here would have a hypotenuse of square root of 2? Well, that is my hypotenuse here. And it would have a side of 1. Well, again, you got two 45-degree angles. The answer is going to be a 45-degree angle. So my angle here is going to be 45 degrees. Now, if you think about it, if we're trying to figure out what that would be in radians, here's how I kind of think of it. Here's pi. 45 degrees, there's like, if you think about pi, there's 4 45 degrees is in pi, right? So if I took 180 divided by 4, I'd get 45. If I took pi divided by 4, I would get pi over 4. So that's pi over 4. And again, another way to do it would be to use your conversion ratios. You really want to get to where you know that pi over 4 is 45. You want to know the fact that pi divided by 3 is 60 degrees and pi divided by 6 is 30 degrees. You kind of want to know those because they just show up so much. So try to get to the point where you at least know these without having to do the conversion every time. But if you had to, what's 45 degrees in terms of radians? I don't know. I'll call it question mark or x. It would be 45. When we cross multiply, we get 45 times pi, and then we would divide by 180. And the same thing as multiplying by 1 over 180. And it would reduce to, man, I messed that up, 45 pi divided by 180. There we go. 4, pi over 4. So in degrees it's 45 degrees. In radians it's pi over 4.